All right, so today we are going to do something called composition of functions. So a function is basically a set of mathematical directions that sends, some element to a to another one. So a very simple function would be f of x equals 5x minus 3. Very straightforward. So your input is your x, also called your domain. So your input, which we call the domain, right? So what do we want to be in our domain? Well, we can put anything in for x. So my domain is actually all real numbers. Okay, so I can put any real number I want into x. Now, so for example, if I asked you what is f of 3, you would simply say, well, f of 3 is going to be 15 minus 3, or 12. So f of 3 is 12. So that's pretty simple, right? Or f of maybe negative 4 here is going to be 5 times negative 4 minus 3, which is negative 23. Okay. So it's pretty easy just to evaluate a function, right? But you can actually do kind of more of a composition of functions, which means what I can do is I can actually put in some other version of x. So for example, I'm going to use the same, let's switch up our function actually. Let's do f of x equals x squared plus 5. Okay. So if I did x squared plus 5, what would be f of 2x? Well, f of 2x in this case is going to be 2x squared plus 5. Basically what happens is wherever you see the x, that's where you put whatever's inside here. So wherever I see the x, I have to put in 2x. So 2x squared plus 5, which is 4x squared plus 5. And so we're done. So I just want you to simplify. All right, so let's do another one. What if I said f of x equals 3x squared minus x plus 1? Okay, this one's a little bit more complicated. And let's say I wanted, what is f of 2x? Well, not that hard. We're going to do 3. Here's an x, so I got to put 2x in there. Here's another x, so I need to put 2x in there, plus 1. So basically, when you do your input, what I would generally do is always use parentheses. That way you'll never make a mistake by putting in too many parentheses. You will make mistakes by not using a parentheses. So use parentheses whenever you can, basically, just to kind of be careful here. So anyway, what is this? Well, this is going to now equal 3 times 4x squared minus 2x plus 1. Or 12x squared minus 2x plus 1. That one's fairly straightforward. So let's use the same f of x though, and let's do what if I want f of x minus 3? Okay, well this one's going to be a little more complicated because I'm going to have 3 times x minus 3 squared minus x minus 3 plus 1. Now in this case, my use of parentheses is extremely important. One, it tells me that I need to square this thing, which if I have to square x minus 3, I need to go through the whole process of distribution. So in fact, this is going to equal 3. Then this squared, remember, is x squared minus 6x plus 9. Again, my use of parentheses is extremely important here because now I realize I have to actually distribute that subtraction. And then I have plus 1. This gives me 3x squared minus 18x plus 27 minus x plus 3 plus 1. Now I can combine all my like terms, which 3x squared is the only x squared. My x's are negative 18 and negative right there. And so this is going to be negative 19x. And my constants are 27, 3, and 1, which make 31. And so here's my function. Here's f of x minus 3 reduced or simplified. So that's kind of how you do composition of functions. Yeah, let me do maybe one more of those just to make sure we've got that down. So let's say I have f of x equaling x squared plus 3, and I have g of x equaling 2x minus 5, and let's say I have h of x equaling, we'll just say x minus 3 over 2. Okay, so let's do that. So let's do maybe, let's do f of the square root of x minus 1. Well, if I want f of the square root of x minus 1, I go to f of x. I say, okay, well, in place of x, I need to put the square root of x minus 1. So I'm going to do the square root of x minus 1 in parentheses. I'm going to square it, and then I'm going to add 3, basically the continuation of f of x. A square root squared just goes away, and we get x minus 1 plus 3, or simply x plus 2. So that was fairly simple, right? Okay, now the next thing I want to do is called a composition of functions, meaning basically I'm going to compose a function using two other functions. So what if I said, so here's the this is going to be sort of tricky here. So I'm going to do h of g of x, like so. H of g of x. What this means is that I'm going to look at my function h, but whenever I run into an x, I'm not going to put an x there. I'm actually going to put the entire function of g of x. So this is actually going to equal, okay, h has an x in it right away. So instead of this x, I'm actually going to put 2x minus 5 minus 3 over 2. So what does that equal? Well, that's 2x minus 8 over 2, which now I can actually cancel out the 2's because 2's can be canceled out from everything, and so it's x minus 4. So h of g of x is in fact x minus 4. Let's do another one. What if I did f of g of x? Okay, so I'm going to do f is on the outside, and whenever I run into an x, I have to put the entire function of g. That's what this thing means. So the f is x squared plus 3, but instead of x, I'm going to put 2x minus 5. So it's going to be 2x minus 5 squared plus 3. Again, this thing squared means that it's actually going to be 4x squared, right? 2x times 2x is 4x squared. Then I'm going to get 2x times negative 5, which is a negative 10x, but I'm going to have to do the other one as well. So I'm going to get negative 10x and then negative 5 times 2x, which is another negative 10x. This is now going to be negative 20x. Then negative 5 times negative 5 is positive 25 plus 3. And so my answer is 4x squared minus 20x plus 28. So that is the, so what that is basically a composition of functions. You can also do a composition of the same function. So what if I did g of x? So that means in place of x, I'm going to put another function of g of x. So in this case, it's going to be 2x minus 5 minus 5, right? So g is the 2 minus, but the gx is right in there, right? So 2g of x minus 5, because that's what g of x was. This now equals 4x minus 10 minus 5, which is 4x minus 15. So that's our composition of functions of g of x. Excellent. Nice work. Let's do... just because I have one of these on the homework and I know it might confuse a couple people. So let's try, what if I had f of x equaling log base 2 of x, and then g of x equals 2 to the power of 5x minus 4. Well, the nice thing about these two is that when I ask you for f of g of x, it actually is log base 2 of 2 to the power of 5x minus 4. And if you remember your logarithmic rules, this basically is 2. If we rewrote this, this would mean, 2 to what power equals 2 to the 5x minus 4? Well, clearly it's 5x minus 4. So this thing is 5x minus 4. So f of g of x is just simply 5x minus 4 there. All right, I want to do one more thing, and it's called, so the last little portion of this is called finding the inverse function. So basically what the inverse function does is it is the exact opposite of your original function. So the inverse function would be like, if I give you a set of directions, and then you would want to reverse those directions, right? So for example, to put on your shoe, you first put on your sock, then you put on your shoe, then you tie the laces. Well, the directions to take off your shoe, which is undo the laces, take off the shoe, then take off your sock, right? So you do the exact same operations except opposite and in the opposite order. So how do we find what the inverse function is? Well, the way you do it is basically the inverse function is the switching of the x and the y. So if f of x is 5x minus 4, to find the inverse function, what we do is we just switch, we rewrite this as a x and y function, except instead of f of x sort of stands in for y, but what we're going to do is we're going to rewrite it and flip the x and the y. Okay, so to find the inverse function, you are 1, flip x and y. 2, you're going to solve for y. And that's it. Those are just the two, those are the only two directions to finding the inverse function. So if I wanted to solve for y here, my first thing would be to get rid of the 4. So I'm going to get x plus 4 equals 5y. Then I would divide both sides by 5. And so I'm going to get, right, divide by 5, divide by 5. So y equals x plus 4 over 5. This is my inverse function. And the way we write an inverse function is we write a little -1 as a power. It is not technically taking the function to the power of -1, so don't think of this as an actual power. It's just a symbol. It's a symbolic symbol for the inverse function. It is not, in fact, it does not actually mean taking the function to the -1 power. And so our inverse function, though, is x plus 4 over 5. Now, the neat thing about this is that when I do a composition of functions and I do f of f inverse of x, okay, I'm going to rewrite this function, but in place of x, I'm going to put my inverse function. Now, this will always happen, okay? So 5, x plus 4 over 5 minus 4. We notice this is just going to be x plus 4 because the 5s are going to cancel, minus 4, which is equal to x. This will always happen. Always, f of f inverse of x will always equal x. This will always happen. The opposite is also true. F inverse of f of x will also always equal x. Let's do one more inverse function though. So, another inverse function. Let's try f of x equals the square root of 2x minus 4. Okay? what would be my inverse function? Well, again, we rewrite this as x equals the square root of 2y minus 4. And then, so we flip the, remember, flip the x and the y, and then solve for y. So here we go. We've flipped the x and the y. Now we need to solve for y. Well, the outermost thing that I need to get rid of first is actually the square root. So I need to square both sides. Now I need to add the 4. And now I need to divide by 2. Done. And there's my inverse function. So f to the negative 1 of x equals x squared plus 4 over 2, like so. One more, just to make sure we've got that down. Let's do g of x equaling 4x squared plus, again, flip the x and the y, so I'm going to write x equals 4y squared plus 7, and then I'm going to solve for y, so x minus 7 equals 4y squared. I then have to get rid of the 4, so x minus 7 divided by 4 equals y squared, and then y actually equals the square root of x minus 7 over 4. And you don't need to do anything else. That's totally fine. We could simplify this a little bit simply because we actually know what the square root of 4 is, but I'm not expecting you to do that, so you don't have to do that. But if one were to, it would be the square root of x minus 7 over 2. But all right, I think we are good. And so I've posted the homework right there as well, so try to do that, but I will also be around on Monday and Tuesday to answer any questions if you have any involving inverse functions. All right, well, enjoy your day, and I will see you soon.